Testing 1 2 3, testing 1 2 3. They're ready to come online. Finally, properly. Yo, what's up? Welcome back to Vencabot. Intro to Python action for real this time. My name is David. Yo, guys. I tried to get started earlier, but I ordered a pizza instead. So let's get this actual show on the road. Our Python show. Speaking of which, where are we in this show? We are on episode 5 of our season 4 of Intro to Python, which, excuse me, episode 6. This is the last episode. So that means we're in our most advanced concepts so far. Intro to Python is a series that runs in 6 episode seasons, where episode 1 is always the very basics of what is a program, how do I use variables, like all that basic stuff, you know, how do programs read, you know, top to bottom, what the hell's a subroutine, you know, what's a code block. We learn that typically on day 1. You know, we learn how to install Python and stuff, and we run Notepad. And then usually every day we stream Intro to Python, we add in new concepts and sort of grow our understanding of programming and Python in particular. And today is the last episode, which means we're in our most advanced concepts. In this case, object-oriented programming. We're talking about classes some more, talking about objects, instantiations, mutability, all these things that we talked about in previous episodes. We're going to kind of review them today and try to put it all together. Our program we're working on this season is a virtual pet, sort of like a Tamagotchi or whatever. It's kind of interesting. It's you kind of name your pets. You can have multiple pets these days. We have 3 of them, Dix, Zanzu, and KD Alpha here. They like certain kinds of foods. You have certain kind of foods in your inventory, and you kind of feed them and keep them happy and play with them to raise their happiness level. And over time, their happiness decreases, and if it ever hits 0, they will kill you, just like in real life. Gotta watch out for these motherfuckers. Hey, what's up, Dagger? He says, wow, what? It's time for Intro to Python, and after that, Pizza and a Movie, Dagger. Hopefully you enjoy it. The movie's going to be The Last Man on Earth, starring Vincent Price. It's actually the first movie adaptation of the book I Am Legend. So we can compare Vincent Price's performance to Will Smith's. What's a I can't read that. What's a dear FD pointer and why do I care? Yeah, I think we're not really too worried about pointers and stuff. We're talking more about Python, which I think is a great language for beginners. The syntax is beautiful. It's very easy to read compared to other languages. Oh, thank you, Dagger. Holy shit, it's a lot of biddies. Pizza and Python? Maybe one day. I think it'd be kind of hard to program while eating pizza, though. So let's look at our code so far. Again, we have this little virtual pet. Let's go play with it first, right? So I have 3 pets. So let's hear, which pet do you want to take care of? I want to take care of Dick Sucker. Long time friend of the channel here. Do you want to feed or play? Let's feed Dick Sucker. We're going to die real fast. So here's the challenge, guys. We actually, in our last stream, we added a new challenge to our game, which is to take care of multiple pets. As we learned about lists and mutability and that sort of thing, we talked about using classes to manufacture objects. We talked about how it's so easy these days to add more pets. Because now that we know how to use classes, we can make similar objects very quickly without too much programming extra, right? So we're able to make a lot of kinds of food very easily and a lot of kinds of pets very easily. And so now we've got 3 of these guys. The problem is that every turn, all of their happiness declines. So we can only take care of 1 pet per turn, but all their happiness is going down. So it's kind of hard to survive. I guarantee I'm going to die here pretty quick. But yeah, so we have Dix here. He likes to eat dick, as his name would imply, right? It makes him super happy. Let's give him some dick. Okay. Boom. So now he's super hungry. He also took a huge shit. Right? So basically in this game, if your hunger level reaches 0, so you're totally full, you take a dump. And then your hunger goes back to maximum. So now he's kind of hungry again. Right? And Katie's also kind of hungry here. Seems like Zanzu's not that hungry right now, though. So the problem with taking a dump in this game is that if you don't clean up that dump, then all your pet's happiness will decline faster. They don't like being in an environment where there's shit on the ground. Unlike me, that's kind of my thing. So the problem is that I have to clean up this shit now. But that means wasting another turn as their happiness is still going down. I'm going to take care of Dix here. And I want to clean the floor. Okay, so we clean up the poops. And we clean the poop right there. That's great. But now Dix and Katie are still kind of hungry. Their happiness is going down. We know that Dix's happiness is kind of high right now because he ate dick. That's what he likes. So we got to kind of feed KD Alpha, I think. I don't know where Zanzu's happiness is, though. We have no warning about happiness unless we try to feed them or play with them. That'll give us a warning. Maybe out of a scope question, what are you using for parsing command line arguments? Wait, never mind. That's irrelevant to input. Yeah, we're not parsing any command line arguments. We haven't done that ever in Intro to Python. But it's a pretty cool skill to learn. We haven't really talked much about the command line here. I try to avoid it whenever I can. It's not really, like I said, within the scope of this show. Even using like CMD. In our first episodes when we're using Notepad to program, we use the command prompt to run our Python scripts. And it's kind of awkward to explain to total novices, like, you know, go here's the program CMD, use the CD command to change directories. I'm kind of trying to avoid the command line if I can. That's cool. That's the cool thing about idle here, which is the editor for Python that comes with Python. If you download and install Python, you get this editor with it. It's kind of like Notepad, but it has some syntax highlighting, so you can see different colors for different things. Makes it easier to read. It has a nice, cool colored background. And furthermore, you can actually run your scripts right here from within idle, which is nice, compared to having to use CMD or having to double-click an icon in the folder. Okay, so we have a problem here. Dix and Katie are both hungry, and we don't know Zanzu's happiness level. Because we don't know Zanzu's happiness, we gotta feed KD right, because we know that he's at least hungry. Then we gotta go focus on Zanzu. So let's take care of KD. Right now, case is significant. You have to use the right case. I want to feed KD. And let's feed him a cheeseburger. Everybody loves cheeseburgers. Please don't poop. Okay, so he's in high spirits. That's great. Right? And Dick's kind of hungry, but who cares? Who cares about Dick Sucker? Right? We just fed him some Dick. He's got to be pretty happy right now. You would hope. So now let's feed Zanzu and make sure he's happy. Oops. I misspelled it. I misspelled Zanzu. I forgot how to use the command prompt there. Oh, that's what you mean. That's what you meant by that, Quentin. I mean, these command prompts, yeah. Yeah, I'm not really parsing anything here. It's really just one-word strings for now. If you want to look at some actual parsing, go look at our last... Was it our last one? No, I think it was the Season 2 of Intro to Python on YouTube, which was our Zork-like adventure game. We actually had some parsing going on there for our strings. Okay, so I want to feed Zanzu cheeseburger. Burger. So he's in high spirits. Okay, so we're doing pretty well right now. So we know that KD isn't hungry yet. And Dix is in high spirits, more or less, but he's been hungry. So let's take care of Dix again. Zanzu seems alright. He's not hungry and he's also in high spirits. I want to feed Dix a cheeseburger. If I feed him a dick, he's going to shit again, which I don't want to do. He's really ecstatic. He does a little dance there even. He's so ecstatic. Right? Sweet. So now all of our pets seem to be happy and more or less fed. That reminds me, do they get more hungry over time? Let's go look at our code here real quick. So here's our code for our program. It's relatively short for what it is. We're trying to keep these things simple on Intro to Python. But if you're a total novice and have not seen episodes 1 through 5 of this season, you might be a little bit overwhelmed. I apologize about that. Again, we're on episode 6 here, which is the most advanced we're going to get. So it's a little bit much. But even then, for a lot of us, it's pretty simple. Okay, so let's break this up right away into the sort of layout of the program, right? What's kind of interesting about being a programmer is that sometimes the code you write is, only equally important to how you lay it out. If you lay out your code in a sensible way, it's easier to improve upon and edit and expand upon later. You want your code to be very readable. And so let's break this down real quick. So over here at the top, we have our classes, right? These are the sorts of conceptual objects we have in our game world, so to speak, in this case. Right? They're also useful for all kinds of other stuff, but in our case, we're using these objects to sort of conceptualize our objects in our game world. So we have the pet food, which has a few attributes. It has a food name attribute, like banana or cheeseburger or dick. It has a tastiness value, which improves the happiness of your pet. And you have a fillingness value, which improves their hunger level. So I'm going to fire you out of a cannon if you keep this in one file. What was our last stream here, Quentin? And we're not really, I think that breaking up a file into modules is not really within the scope of Intro to Python. We're really trying to cover like beginner type stuff. So we do typically keep it in one file. Anyway, so we have the pet food object. We have our pet as well. Now our pet has attributes. It has a pet name, like KD Alpha or Zanzu. It's a happiness level and a hunger level, right? And they're all get assigned when we initialize our pet. Right? When we first create our pet, it asks for a few things. A pet name, a happiness level to start with, and a hunger level to start with. Right? And then it defines these attributes for that pet, right, when you first make it. But what's also cool about the pet is that it has methods. We talked before about how attributes are variables that are owned by an object. Right? When we first started programming here on episode 1 and 2 and 3, mostly our variables were sort of floating loosely in our program. Right? They were just a named variable that referred to a piece of data. Right? We would have, let's say, a pet name for our single pet. Right? We would save our pet name, boom, there you are. But now that we have our pets as an object, now we can say here that this pet thing that exists, this object, it owns a pet name. It has a pet name. Right? it has a happiness level. So it's not just saying here, somewhere in our program's, code in the ether, we have these values. Now these values are organized in a sort of hierarchy, right? They are owned by something. In this case, they're being owned by this pet. So now we have this pet, Zanzu or Katie or Dicksucker. They have their own pet name. They have their own happiness level, and they have their own hunger level. Okay. But they also can own functions. So we learned about functions, right? How you can sort of set aside these miniature programs that can take input as arguments and output data as return values. And you can have them sort of do their own thing. Well, what's cool about objects, they can actually own functions. They call them methods in that case, right? So if you own a variable, it's called an attribute. If you own a function, it's called a method. And these methods are kind of cool because you can have these operations that are attached to these objects, right? So you have this eat method here, right? So we're saying here that, our pet can eat things, right? And it eats this pet food as its argument. And what's really cool about methods is they always have access to the self value. And self refers to the object itself. So we have this, eat function, eat method, which can look at the food's tastiness, right? Because the food is an object itself. And it can also raise self's happiness, right? Because our pet here has a happiness level. So typically you can organize your methods underneath objects such that they can sensibly relate to that object, right? Because we know that when you eat something, it's going to be messing with that pet's values, right? The pet's doing the eating, so its hunger will go down, and its happiness might go up or down, depending what you feed it. And likewise, you're feeding this pet food, so you can mess with that pet food's values as well. We know that the pet food has, a food name, a tastiness level, and a fillingness level, right? So you can see here as the pet eats, it uses that food's tastiness, here's up here it goes, to decide how happy to become. Right? So here, if the tastiness is above 70, then become more happy. Right? And if the food's tastiness is below 40, but between 20 and 40, then it says here lower the happiness. If it's even lower than 20, then really lower that happiness. Right? So pets only like tasty food, kind of like me. Finally, after you eat, it prints off a message about how happy you are or aren't. Right? In fact, that should be its own method probably, right? It should be like report happiness. We should do that right now, in fact, right? So let's go here. After the pet eats the food, it changes its values, right? It prints off, so-and-so eats the food. We're going to actually copy this happiness level type stuff here. Okay. Cut that out. And make a new method. Right, so say here, def report happiness. Right, self. This is a method here that takes self as the only argument, and we're going to just have it report the pet's happiness. Boom. All it does here is say, hey, if you're this happy, then say this. If you're this happy, well, then say this. Right? Now we can use this in other methods if we wanted to. I'm going to say here, after you eat the food, I'm going to say here, self.report happiness. We talked before about how, unlike most functions, where you have to supply every single argument, if you have a method, it actually takes self automatically. So you don't got to worry about putting that in there. There's an empty little, you see the empty argument list here. That's fine because it's only self, and self you can just leave out. If you supply it, it's going to cause a bug. Just leave it out there. User debugging Python, huh? Yeah, we have plenty of condescending trolls around here. You don't want to compete with Dix for that prize. Dix will always win. Alright. So we can also play with our pet. It has this big old, subroutine, this big method here where you play with your pet. And it won't play with you if it's too hungry. Right? Also, if it's not happy enough, it's not going to play as enthusiastically, which is kind of a way to see how happy your pet is. Okay, also has a little simple dance method here where we can dance around. That's all it really does there. Okay, so now we have our functions, right? So we're talking about how our program is broken up, like, in our file here, in our one towering file, which Quentin is not a huge fan of. As you become stronger programmers and your programs become more complex guys, it can become very important to break your code into multiple files to make it easier to read. In this case, we have our classes on top. We have our classes on top. Then we have our functions. These are the simple functions we use to sort of allow the player to input commands. And these are based on commands right here. So we have the input pet activity, so it's going to ask the player to, you know, to type in what they want to do. We have the run player command, which will take a command and map that, return a function to run based on that command. We have our feed pet function here. All it does is it asks you to feed the pet from your inventory, then it runs that pet's eat command, right here. So it says a pet.eat chosen food. As you guys know, we have an eat method here on our pets. Right, they have an eat method. So we have this function on here that it asks the player what kind of food they want to feed the pet, and then they run that pet's eat method on that food. You can put the pet to bed, you can play with it, you can clean up the poop on the ground, you can cheat by using the dagger cheat, which is awesome. And you can end the whole end turn subroutine here. The end turn function. Where it kind of ends your turn, it makes the pets more hungry, makes them, you know, more happy. So here's the thing, here's what I want to find out, right? I want to find out if your pets become more hungry every turn. They don't seem to. Right? When you end the turn, it says, if the pet's hunger is greater than 70, then report they seem kind of hungry and they get unhappy. Right? They lose happiness if they're hungry. Kind of makes sense, right? Kind of like I do. It says poop on the floor. They also lose even more happiness. And if their happiness is below or equal to 0, it's game over. They kill you. But they don't get hungrier over time, which seems like an oversight, right? So because now in our game, we have Dix and Zanzu and Katie Alpha all fully fed and all pretty much happy, we have essentially won the game, but not doing anything right now, right? We've basically won. That's kind of a problem, right? Maybe we should make the pet get hungrier over time. Every turn they get hungrier. Does Dix have an opinion on removing null values from programming languages? You want to remove the null value? What the fuck is wrong with you, Quentin? My opinion is to keep that nerd shit away from me, huh? It might be contagious. You need entrance music, huh? Yeah, we do need music for Dix. We will have that one day. In the play with function, what is the first if statement actually return? Let me find out. mTOR. I bet it's nothing. I'll explain to you why it's nothing. It's a little trick. Maybe it's not even really fit for beginners. I should probably have maybe not used that, but it's a little trick that can make your program a little bit neater looking. So let's go to our play with pet. I'm sorry, I missed it. And play with function. I think maybe you're talking about a different... oh, maybe you mean up here in the play with method. Here it is. Okay, okay. So we have a return right here, right? This is what you're talking about. And this return here is similar. So I'm using these return values here. They return none, right? Return with no value is the same as return none, right? It's also the same thing as ending a function. Anytime you end a function or method without a return at all, like, you know, return, self.hunger, that would return an integer, right? But if you return none, it returns Python's value, which means nothing. None means nothing. It's a value that means nothing. And if you just return, it means the same thing. The none is implied. But finally, if you end a function or a method without any return, it implies return none. So every method and function always returns. There's always a return value. And if you don't specify it, it's just none. Right? So that's one thing you got to know. The second thing is that when you call return before reaching the end of your function, it will immediately end the function. That's why I'm using it here. Okay. So if you return without actually hitting the end of your function, it will end your function hard. It just forces it to end. Right? So what I do here is I'm saying, if the pet's happiness is below 50, then print off they're not in the mood to play, and then end the function. All right. Now the reason I do this, the alternative, which would maybe be a little bit more sensible for a beginner, would be to say this. You know, if their happiness is below 50, then say they're not in the mood to play. Else, you know, if they are in the mood to play, well then, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Well then say here, okay, well if their hunger is greater than 60, well then they're too hungry to play. Okay? Else, you know, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, etc., right? So basically, I'm saying here, you know, if they don't want to play, well, then print that off. If they do want to play, well, then are they too hungry to play? And if they're, you know, if they're not too hungry to play, well, then do this. And as you can see here, it means a lot of indenting. It means a lot of indenting. So a little trick you can use, again, this is not really limited to Python or anything, but it is a little trick you can use, which is to, instead of doing these deep indentations, instead force your function to end. Now, if we weren't in a function, we wouldn't have this luxury. Right? But now what I'm saying here is, let me actually translate this for you now. So now what I'm saying here is, you know, if their happiness is below 50, well then, you know, end the program, end the function, end the method here, right? And if we made it this far, then we know this one above didn't trigger, right? Because if this did trigger, then we would have ended the function already. So I don't need to use else. I don't need to indent, right? Because by virtue of us having gotten this far, we know that the following, the previous, did not trigger. So it's kind of a way to save on indenting. That's kind of the way you use this. It only works within a function, or within a method. Or sometimes within a loop, because you can use continue or break. But that way you can kind of avoid indenting. That's really the way I'm using this here. I'm saying, if this is true, well then end the program. Well, if we haven't ended the program, end the method. If we have not ended the method yet, well then we know that wasn't true, so keep on going. Okay, well if this is true, well then end the method. Return. And if neither of those were true, well then keep on going. Right? I could have used else, but we don't really have to, because we're inside of a function here. Is there any reason you don't just assign the statement to be printed to a variable and return that string to reduce the number of repeated printfs? Or are you doing this for readability? I'm going to reread that and answer that question in a second here, Tron. Kind of like those close brackets in C# or JavaScript. Maybe a little bit. You could then do a single return, which avoids the pattern of multiple exit points to your method. Does it affect runtimes? No, it doesn't. No, not at all. Is there any reason you don't just assign the statement to be printed? Oh, well, yeah, because we're printing a lot of stuff. Yeah, we're printing a lot of stuff. Or we print inside here. Right, we print off, you throw the toy, we print off this stuff. Yeah, if its happiness level is above this, yeah. It doesn't just return a value. It doesn't always terminate in a string. Yeah, so I guess what Tron's asking, if you guys are kind of beginners here, he's saying, it seems to me that this function, what it really does, is it gives you back a string, right? We get a string here, we get a string here, and we get some strings around here, some strings around here. I guess what he's saying is we could just return this string and then have it be printed off somewhere else. But in this case, let's not do that. Only time you really need to worry about runtimes is when you're writing algorithms for collections of various data structures. Thank you, Quentin. Yeah, he has a point though, mTor. You don't really have to worry about optimization too much in Python. Typically, what you want to do is make your code as readable as possible, as usable as possible, as sensible as possible, and then if you're having problems with speed, then go back and optimize it. That's a sort of a programmer credo. They're really good questions, yeah. For more advanced Python courses, keep in mind this is for Chapter 1 beginners. It's actually Chapter 6 for beginners. I do appreciate the questions. Yeah, in any case, no matter what level they are. So I can't always answer them. It might be a little bit more of a kind of a complex, time-consuming answer that might not be fit for this discussion here, but still very good questions. Yeah, especially Tron wants a very good point. What's up, Tron? Welcome aboard, bro. Yeah, I wish we really had time to talk more about the mentality of return values. That's kind of what Tron's getting at here, is the mentality of return values and how to use them efficiently. I think it's a really great topic, maybe not fit for this tutorial here today. Okay, so let's go. We have our classes up here, our functions down here, and finally, after all of our functions and classes are defined, we have our actual, you know, like the main. You know, if we were learning about main, we could say here, you know, if name equals main. I'm not gonna worry about this today. We'll talk about that maybe in a future stream. A little more advanced. It's not really that important. This is our main block down here, right? Where things actually finally happen in our game. So we talked about in previous streams about code blocks and how they don't necessarily run. Oh no problem, Tron. It's always a pleasure, dude. Pleasure having you here. So it's a very good question. If we were on episode 7 or 8, that'd probably be we have to talk about that a little bit. But we don't really get into that too much in Intro to Python for total noobs. In fact, we don't really touch on return values that much at all, except for in episodes like 3 or so. Anyway, so all these classes and all these functions, they are code blocks, right? And in some languages they're called subroutines. That means that although they are defined, they're being defined, they are not being executed, they're not being run, right? Python always defines things, you know, it reads instructions in order, top to bottom, unless they're indented. Then it will ignore these instructions unless a certain condition is met. For a class, it means that you have to sort of instantiate the class. Right? For a function or a method, it means you have to call that function or method. So although we have all this code up here, we're laying it out for future use. It is not being executed. Right? We're not starting our program and having all this shit happen. This stuff does not actually happen, until we actually use it later on. So we defined some classes. We defined our pet. We defined a bunch of functions. Right? But none of this stuff actually has happened yet. We're just defining them to use them later. But down here, you can see that our code is no longer indented. Right about here. This is the part of our program where things actually start to happen. This is where things are actually happening in our program now, right? We're using that stuff we defined above, and we are finally calling it into action. For instance, here we're making some of our rpets, right? We have this rpet class. We're finally making some of these rpets. Right? We make a dicksucker, for instance. We call him dicksucker, right? We have this dicksucker variable. We made a new rpet, gave him a name, gave him a happiness and a hunger value. Same thing with Zanzu, KD alpha. We also have a TF dagger. We're actually not using TF dagger in our code yet. We have a Vencabot pet as well. It's not being used. After that, we define our GameState, right, which is sort of like this dictionary that contains pieces of data we need for our program. It's sort of like the whole state of the game. And we have a list of pets in this GameState, right? We only have 3 pets, right? Dix, Zanzu, and KD. We define them right here. Here's Dix, here's Zanzu, here's KD. We can always add in Dagger back to our list of pets. We defined him right there, after all. And Vencabot, why not, right? Now we have 5 fucking pets. Right? Crazy. That's crazy. It's actually crazy. Programming is easy. Debugging is hard. Well, you say that, but of course, if it's your first day programming, your first week programming, it's not easy. It's not easy to understand things that I take for granted, man, as a programmer, for the last 20 years. Some things that people are confused by, I take for granted. Like, the fact that programming is read from top to bottom, the fact that this indented code up here is not being executed. What is the purpose of these things? Some guys might not know. Like, why do you define these functions? I'll try to cover that. If it's episode 6, though, guys. If you want to learn about that, check out our YouTube channel at youtube.com/Venkabotarchive. We go into details about that when we discussed, what is a function and why do you use them. We're kind of getting into more, some more complex stuff now than that. I'm pretty good at handling people's Python. Not so good at programming, huh? Wow, dicks. Python is hard, programming is hard, debugging is endless, and drives people to craziness. That's true. Definitely true. Yeah, it's relatively easy indeed. It's relatively easy. But for beginners, it's a lot to learn at first. But it's a lot of fun too. It's worth it. It's worth it to learn. Anyways, we have this poop on floor value inside of our GameState dictionary as well that reports false. There's no poop on the floor at the start of the game. We also define this taking care of pet value, which is true, which means that we're still playing the game. Once this becomes false, then we stop playing the game anymore. I just gotta think we start over. Welcome aboard at Soulshine. I apologize, bro. This is episode 6 of a 6-episode season. So we're kind of in more complex territory now. If you're a total beginner who's never used Python or any programming language before, check out YouTube. We have a YouTube channel at Vencabot Archive. Just search on there for Vencabot on YouTube. You'll find all kinds of cool tutorials, not only for this season, but previous seasons as well. Season 1 was a Pokemon game we made from scratch. We also did a Zork-like adventure game. We did an RPG adventure game. We did all kinds of crazy shit already. It's a lot of fun. Episode 1 is always how to install Python and what is it and how do you use it. And over time, we add in more complex ideas. We have some new food here. We defined a bunch of food. A banana. It's a pet food object. Remember, we have these 2 classes, right? We have these 2 classes up here. Pet food and our pet. So we're defining these objects, right? We're using these molds, a class like a mold, right? We're using these molds to manufacture objects. And that's why we're able to have 5 pets at once. Because it's, previously if we had not been using object-oriented programming, making 5 pets would be a lot of fucking code. It would be a ton of code. But thanks to this mold we have, this class, we can make pets this easily, right? Our pet, a few stats, there you go. Now these pets can all eat, they can all play, they can all dance, they can all do the same things because they're made from the same mold, but they do have varying attributes. Right? So thanks to this class idea, we're able to very quickly manufacture objects. We also have this pet food, right? We're making a whole lot of pet food here very quickly. Banana, pie, mushroom, cheeseburger, and dick. Delicious, delicious dick. Right? And now we have this game state value here, the food inventory. And it's really more like a food menu than an inventory, right? Because we never remove the food. We're probably going to do that today, to be honest. But yeah, so right now it's more like a menu of food you can choose from. And we're putting in the banana, the pie, the mushroom, the cheeseburger, and the dick. Right? And here's our list of commands in the game. It's a dictionary that points the excuse me, Quentin asked earlier how this works, right? It's a dictionary that points the command you type in to the function to run. That's really all there is to it. Right? It's very simple. So it's a map. You know, dictionaries are also called maps in Python. It's a map because it maps the value on the left, the string you're going to type in, to the value on the right, which is in this case a function to call. So if you want to type in the feed command, it runs feed pet. If it's play, play with pet. Quit, you know, puts the pet to bed. Clean is clean up poop. And if you type in dagger, it's the cheat command. Right? You don't use an IDE, just idle exactly, Blue Barn. Yeah, we're really beginners here, and on our first episode of the season, we always use Notepad. That's how I started. I think that a lot of total newbies might be under the mistaken impression that you have to have all kinds of cool software to program. You don't. All you need is Notepad to program, right? And we're still keeping it simple. After day 1 or 2, we stop using Notepad. It kind of sucks. And we move on to idle, which comes with Python. It's not really the most feature-rich IDE out there, but it is available to any newbie that has installed Python, which is great. It doesn't involve installing any, or learning any new software. Okay, so then we print off a blank line once we define all this shit. And then we have our pet map, which is a map, it's a dictionary of the pet name to the actual pet object. So here we have these pets we made, right? And all these pets have a variable name, of course, which we can't really access through a string. I mean, we technically can, but let's not touch on that today. But we also have a string for each pet, right? That's their pet name. Right? Dicksucker, Zanzu, KD Alpha, TF Dagger, and Vencabot. Right? They have an actual string that is their name. So if I want to access that pet by its string, I have to map that string to that pet. Right? So here we have a dictionary that says for pet in our pets list, GameState's pets, I say here, the pet map, add a new key, which is that pet's name, and make it point to that pet. So now we have a dictionary here that looks like this, right? It looks like this in the end. It's like Dicksucker is the pet Dicksucker, right? Vencabot is the pet Vencabot, etc., 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 etc. So now we've used this for loop to iterate, to go one at a time through each pet in this list, and say for that pet, add its name to this dictionary, and then have that name point toward that pet. So now we have this, it's a pet map. It maps their names to the pets. Beware of stashing functions as hash map dict values. I missed out on a job because I did that. What? But for beginners, a sensible approach for accessing functions in a reasonable way. It's on YouTube and as well, Blue Barn, yeah. Yeah, it's actually, go to youtube.com/Vencabot archive, or just go on there and search for Vencabot. You will find lots of gameplay. We're really like a variety stream here. But you'll also find a playlist for Intro to Python, which is tutorials. And we have, this is season 4. And each season is a 6-episode season, where episode 1 is what is Python, how do I install it, what's a program, what's a variable. And then every day we add new ideas, and we kind of learn a little bit more. This is the last episode of the season, which is the most complex. If you're new here, I apologize. You might be a little bit lost. Go check out YouTube, check out episode 1 or 2 or 3. We also have a Pokemon game we made. We did a text-based adventure game. We did a text-based RPG, sort of like Dragon Warrior, but with no graphics, of course. We're not really touching on graphics too much. This is Season 4 of Virtual Pet. Okay, so now we're saying here, while we are taking care of our pet. So we talked before about how this taking care of pet value, right up here, it defaults to true. We defined it, when the program starts, we make it true. But if we ever die, if our pet kills us from being too unhappy, it becomes false. Right? So that kind of refers to, whether the game is still running or not. That value there is it's a Boolean value. A Boolean means a true or false value. And it kind of determines whether the game is still running or not. In fact, if you look down here, you'll see how that works. Right? It's called this while loop. Right? As we have this while loop, while this is true, right? While you're taking care of the pet, then keep on playing the game. This is pretty much all the game code. Right? I should say the main game code. The main game loop. And once you are no longer taking care of your pet, this becomes false, then you break out of the loop, and you end up down here in print game over. All right, so let's say I'm going to go over here right now, and I'm going to go to, let's say, Dicksucker, and I'm going to feed him something he really hates, like, I don't know, mushrooms. Okay, he's still ecstatic, though, because he's really, really happy from eating that dick earlier. So I'm going to take care of Dicksucker again. I'm going to try and make him really unhappy, just like every stream that I do. Feed. Mushroom. Okay, he's in high spirits now. He's not ecstatic anymore, huh? Is Dix a male? Or did I assume his gender inappropriately? Yeah, Dix was a dude. He's a dude that loves some dick. Let's say, which one do you want? Potato or Dick Sucker again? Let's go, Dix. Dick's always on the clock, dude. Mushroom. Now he's mad depressed. So now his, if we look at our code here, it says he's mad depressed. Let's go up here to our report happiness method. So we fed him a mushroom, right? So this eat method on our pet. He eats a pet food. And mushrooms have very low tastiness. So that will lower his happiness by quite a bit when he eats it, right? Basically, if your tastiness value is above a certain amount, then you get more happiness. If it's below a certain amount, you get less happiness. Right? We print off here, self.petName eats the petFood.food name. Right? So it says right here, Dicksucker eats the mushroom. That's this line of code right here. The pet name eats the food name. And we could use F strings there. Do we know about F strings yet? Did I cover that in the season? Do we have any F strings here? We do. Let's make it an F string. Make it a little bit easier, right? So we learned previously about how in Python 3, in a recent update, they added the ability to do these F strings, which are strings that sort of simplify the process of putting variables into your strings. In this case, we're using concatenation, which means that we are using a string here, the pet name, and we are adding it, or concatenating it, to this string here, which we are then also adding to this string here, which we are adding to this string here. Is it Python 3.6 or is it 3.4? Anyway, so we have this big old block where we're adding a bunch of strings together, right? Why don't we make it into an F string, where by putting an F here and then putting a string, you know, we're starting a string, right? So when you make an F string, you put an F and then a quotation mark, and then for every variable name in your string, you surround it with these curly brackets. It's a little bit easier to read. It's a little bit shorter to type. It's a little bit neater in general. I love this feature, F strings. I really wanted to drive home at first the way that strings are added together. It makes more sense for beginners, perhaps. But now that we're a little more intermediate, let's use F strings. So we have this F string here now, right? It says here, self.petName eats the petFood.food name. That's an F string. So we can use these variable names right in our string. Don't gotta actually add them all together anymore. It's kind of cool. Hey, what's up, Walk and Talk, Stephen Hawking? I'm doing great, dude. It's Pizza in a Movie Day. I'm really excited. I always love pizza in a movie. For the future, if you're unsure of someone's gender, use they, there instead of his, her, or she, her. Here goes with the advice in the chat. Okay, so after we're done eating, we report happiness, right? And here's our method right here for reporting happiness. So we saw that Dix seems mad depressed. Right there. And that's right here. So we know that Dix's happiness level is below 25. So it's almost game over, right? If his happiness was above or equal to 80, he would seem ecstatic. We could use more F strings here. Let's do that. Oops. Can't type for shit. Okay. See what I did there? So I used these curly brackets around the variable name to avoid having to kind of add it together with a literal concatenation. So now I want to do the same thing here. If its happiness is equal to or above 50, but below 80, then we can say here that self.petName seems in high spirits. And finally, you know, if we're not above or equal to 50, but we are above or equal to 25, then we can say that so-and-so seems kind of down. And finally, if we're actually below 25, then it says that so-and-so seems mad depressed. That's what it said right here. Dix seems mad depressed. That means he's very, very low happiness. So it's probably close to game over. If it hits 0, it's game over, guys. Awesome. So I'm going to feed him one more mushroom and probably destroy the game. And what's going to happen here is we feed him that mushroom, and it's going to say right here at the end of the turn, let's go to our end of turn code. Right here. It says that at the end of the turn, it says, well, if the pet's happiness is less than or equal to 0, then, you know, so-and-so bites you and then poops in the dang carpet. You faint from embarrassment and then the game state taking care of pet value becomes false. Right, that becomes false now. And when that becomes false, as you guys know, we go here to our main game loop. End turn runs right here. And if we go back to the top, because it's a while loop, right? And the taking care of pet value here is false, then we drop out of the loop finally. End up down here, print game over. Right, the game finally ends. There's no more code down here below that, so our program ends. Just says, wow, Venka, I came here to escape reality. It's okay, we'll feed you some dick next time, dude. He's like, wow, if I came here to escape reality, we'll feed you some cheeseburger. So I want to take care of Dix again. I want to feed him a mushroom. This should end the game, I think. Boom. Right, he seems mad, depressed. Dixlinger bites you, then poops in the dang carpet. You faint from embarrassment. Game over. Right, then we're outside our program here. We're actually back to the regular Python shell command prompt. Okay, cool. So that's how our program works right now. I prefer your majesty, lord of the hairy folk. Okay, cool beans. So that's how our program works right now. But we're going to be looking at a little bit more object-oriented stuff today. We have about, what, a little more than an hour to program here still. So why don't we use what we know about object-oriented programming and see if we can add new features, maybe make it a little bit cleaner. For instance, I don't really care for this, all these loose functions we have here. They're a little bit messy, like super messy. Right? One thing I see is that they all take this game state object. Right? It's a dictionary, right? We have this game state dictionary down here. And they all refer to the game state. Right? So if all of these functions require the game state, I think they all do, right? Let's go review that real quick. Do all these require the game state? Let's see here. We've got a game state right there, game state right there, game state right there, game state right there, game state right there. It always needs as an argument, right? Game state right there, game state right there, and then game state right there on end turn, right? So every function requires the game state. Well, what do we know that is a system where all these functions would always have access to the game state? Well, it'd be an object, right? We're talking about methods. Methods always have access to self, right? So why don't we make an object that refers to the game state? We're not asyncing yet. I do kind of want to do that, though, Pancake, to be honest. But I think we're not going to have time, to be honest. Like, what I want to do is get some threading going on here. But we probably don't have time for that. So let's make a new class. Now, we're going to call this, like, the game state. It is scary sometimes, but it's also very powerful. We have this game state class now, right? It's not a dictionary anymore, it's a class. So what do you know about this game state? Think of follow Wisp-Rio. Whisperio? Not sure I can pronounce that right. Welcome aboard, dude. We do Python tutorials here every Friday. And also we do some programming throughout the week as well, but the tutorial's always on Friday. Sometimes I program more casually. I'm not really going through all the details of what I'm doing. Anyway, we have this game state class, and it needs some attributes, right? We have a dictionary right now, you know. It's got values. These could be reinterpreted as attributes, right? So let's go do that. You know, our game state has to know a few things. Init. Did someone say Rio? Okay. It needs to know, it needs to have a pets list, right? Self.pets equals, it's a list. It needs to know self. I will say something like, I don't like this idea of like taking care of pet. Right? We call it right here, it's called taking care of pet, right? Is our value for if the game is still running. Maybe we should just call it running. Right? We'll call it running to say if the game's still running or not. Running equals true by default. Actually, we'll have it be, no, we'll leave it be true by default for fine for now. We also need to have like a menu, like a food menu. It's going to be a dictionary of foods, right? Now make it a list. Okay, and let's see what else we got here that we need to know in our game state. If there's poop on the floor or not, right? And this map of commands. Okay, sweet. We're throwing a how show kokens, huh? Is that what Rio throws in King of Fighters? Those Bobo Hadokens. Self.poop on floor equals false when the game starts. and self.command map. Right, it's going to be a map of methods to strings. The super fireball, okay. Sweet. Awesome. Cool. Poop on floor. Okay, what's got? Food inventory and the command map. All right, so we're all done then. Let's have a pet map here we're going to need, right? Yeah, probably need a pet map. Okay. So maybe instead of having a pets list, we should use a pets map. Same with the food. Right. So our pets there's going to be a dictionary now, right? Okay. And we have a food menu as well. It's going to be a dictionary. Sweet. Awesome. Amazing. Let's try and make it a little bit more sensible how it's broken up here. I'm going to put the... still running true. I'm going to put the booleans on top. Then dictionaries below that, just to make it tidier for your boy Vencabot. I like that more. It's pretty. Okay, we have booleans. We have some dictionaries. That's all well and good. Let's start making these functions into methods. Right? They all require the game state anyway. Right? So let's just do it in order, I suppose. Let's say here, def, you know, I don't like this function name, kind of awkward. Input pet activity, right? Asking for the pet activity. Why don't we say prompt, like prompt for activity, right? And take self now, right? Because now self has access to all this stuff in the game state, right? So we say here, if not self.poop on floor, then say here, our pet activity, we can just return, right? We can just return this value. Right, it says return it. So I'm going to say here, return input, do you want to feed or play? Okay. If we say otherwise, if there is poop on the floor, then return the input of do you want to feed, play, or clean? Okay, I don't have the variable name. That's fine. Okay, cool. So we have this little prompt now. That's great. Easy. Oh, Dix is triggering. Here goes. Troll versus troll. Art of Fighting is a bootleg Street Fighter, huh? They're all bootleg versions of MapleStory PvP anyways. We gotta do that one day, dude. That can probably even have PvP, does it? If it did, that'd be sick. I'll say right now, if MapleStory has PvP, I will stream MapleStory tournaments. Period. Alright, so we can get rid of this function now. We have a method for it. It's a little bit cleaner. Let's go here and say def, you know, run player command. We have self. We've got, we'll say run command with pet, right? So we're going to have self. We're going to have the command, the player command. And we have our pet we want to actually run the command with, right? Sweet. We're going to say here, we're going to try and get our command callable. You know, is self.command map at the player command. And if they don't have that key in there, we're going to get a key error, right? If they try and type in, let's say, like, you know, like dance with pet, there's going to be no command for that. So it's going to give us a key error. We're going to accept that key error. And instead of crashing the program, say, you know, please type either feed, play, quit, or clean. Right. Easy. Awesome. Sorry, guys. Talked before about hanging indents, right? How you can use these hanging indents to avoid having overly long lines. They're not super attractive, but they're better than having a line go off the edge of the screen there. Gunbound was top tier, huh? Gunbound too strong. Me and Dix had a kick-ass time playing Gunbound, kind of. RuneScape PvP tournament for Venka viewers when? I will host. If you'll host, we should do that sometime, huh? You could maybe bring some of your friends. I don't know where to play RuneScape aside from you. If you do RuneScape PvP, can I be on Faust's team? Castle Wars is free to play. Capture the flag all day, huh? Maybe to follow Kanya. Yeah, me too, Dix. That was one hell of a stream. I'm glad we did it, though. Maybe. Because of just how Windows XP that game was. Anyways, let's get rid of this now. Let's actually carry on here. We got our command callable, right? We've got our command callable. I'm going to now say here, you know, run it, right? You run the command callable we got. Excuse me, callable. Using the pet we used, right? There, easy. Oh, yes! And other sound bites as well. Amazing sound bites in that game. I want to remind you guys, we're destroying our program. Right? It's not going to work anymore at all. Because we're changing so much. As a programmer, you have to do this sometimes. You refactor. If you want to make your program more clean, it might mean moving things around and change the way things work. It's going to totally destroy your program. So we have to make sure it works after this. It's kind of a pain. All right, let's now say I want to feed a pet. Right? Take self and pet. We're going to say here... Oh, wait. So I have some kind of weird problem here. Where's my... Oh, right here. I'm missing an end string right there. Okay, so I want to feed a pet. I want to feed it like so, with this stuff down here. Although now we have a food dict, right? We don't have to make a food dict every single time. We have a food dict now. Okay, so let's just say here, you know, print, you can feed the pet. And then we use a for loop to print off every kind of food we have in our menu. So for, you know, pet food in our self.food menu .values. We haven't used that yet. So if you were to use a for loop over a dictionary, not a list. We've done for loops over lists before, right? They go through every item in the list, and they let you do something to that item in that list, right? We're using a dictionary, though. If you do this, then what you get is you get a list of the keys, right? So the keys are the actual names of the foods, right, in our food menu. But we're going to want the actual foods themselves. So you can use the values method of a dictionary and get out a list of its values. The values are the second half of, you know, every part of the dictionary, which means we're talking about the actual foods themselves, which have food names and stuff. So for every food in this, you know, our dictionary of foods, I'm going to say here, you know, print off the pet food's food name, right? Because we know that pet food has a food name, right? It's one of these objects up here. It was manufactured from the pet food class. They all have a food name value. In lieu of key errors, I recommend using get on dict instead of try except, though they do the same thing. Get reduces traceback results. What? Using get on dicts instead of try except. Why do you want to reduce traceback results? Okay, so let's see here. So we are feeding our pet. We're printing off a list of the foods, right? So we have this for loop here that prints off all the foods we have, basically, right? Their names. Okay. I'm going to say here, print a blank line after all that. We're going to get the chosen food name, right? We're going to say here, the chosen food name is from the input of the user, right? What do you want to feed pet.pet name? Right? So what do you want to feed the pet? There's a hanging indent there. There we go. I'm not sure why idle doesn't follow pep8 with the indents. It's whatever. And now we're going to make sure that we actually have that food name in our list of in our dictionary, right? So we say here, try. Our chosen food is our food menu, self.food menu, at the key chosen food name. Right? So if you type in, let's say, cheeseburger, right? We're going to use that string you typed in, you know, this actual word cheeseburger, to get the cheeseburger object out of this dictionary, right? It's mapping the names, you know, the strings, to the actual objects, the actual cheeseburger, right? But the problem here is if you type in the word pizza, we don't have pizza yet. So it's going to crash our program with a key error, because there's no key in that dictionary with that, you know, with that string. So we're going to accept the key error, accept key error, and if there's no, you know, if we type in the wrong thing, we can say here, you know, print, you don't have that. You don't have that food. Right, and then we're going to end our, you know, end our function, return. Okay. But if we actually did get the food we wanted, print off a blank line, and then we're going to have the pet eat it. Right, so we have this pet object. We have an argument, right? We have the argument here for the pet. Use that and make him eat this food. So eat the chosen food. So we're going to use this pet object we defined right here. Right, that's our class. And we're going to use its eat method to eat this pet food. It's going to do all this stuff right here. Right? That's how object-oriented programming works. We're calling a method on this object that we got. Okay, so it's eating this chosen food. Awesome. And now we're going to print off, its remaining hunger. Oh, no, excuse me. We're actually going to have it take a poop if it's full. Right? After it eats, we're going to say here, if pet.hunger is less than or equal to 0, then we're going to say here, print f-string, pet.petName takes a massive dump. Right? Print off a blank line. Change self's.poop-on-floor value to true. Now there's poop on the floor, right? Also, change the pet's hunger back to 100. The dict method, .get returns none or a default value of your choosing if the key that's searched can't be found. This allows for offering a default value for keys that don't exist. Oh, nice. I didn't know that, Quentin. How do you supply the default value? Is that like an argument? It's a massive dump, dude. It's not a little dump. It's a huge shit. It's full. It ate a lot. It's gonna really. It has to be a huge shit, right, John? Because it's immediately completely hungry again. After it shits, its hunger goes back to maximum. So you know it's a huge shit. Anyway, so now we have this. Thank you, Dagger. A massive shit, dude. Just absolutely massive. It's completely hungry again. So now we have this feed pet method, a function, that we have now made into a method. Let's get rid of this old function here. Make our code a little bit tidier. Dict get key I want, default value. Okay. Didn't know you could do that. Interesting. That's nice. Okay, so now we can play with the pet here. I want to actually have this be in our object now, our GameState object, as a method. It's a thing we can do, although some can't be done. Define, play with pet, self, and pet. Right. I'm going to say here, we're going to give them a thrown object, right? We're going to get an input here. Thrown, I'll say like toy string, we'll call it, is input. What do you want to throw? What do you want to play fetch with, right? We're going to say here, pet.play with our toy string. That's what it does, right? If we go up here to our pet, it has a play with method. And you give it a string, right? It's toy, it says. And use that toy there as a, to just kind of add that in here. Retrieves the toy. It's really just a string, really. It doesn't really matter. 3030. Way past the millennium. Okay, so we can play with our pet here. Just needs a string. Awesome. Easy. Easy peasy. Okay, get rid of that. Old function. We can put the pet to bed. Let's go add a method for that. Put pet to bed. Self and pet. And it's going to say here, print off, an F string. Pet.petName goes back to bed. Oops, I'm stupid. There we go. We're going to say here self.pets. That actually removes the pet from the dictionary, huh? I think for a dictionary to use delete. Right? I think so. I'm not even totally sure, but let's go review that real quick. So we actually had a list of pets before. Right? And you can use this remove method on a list to remove that pet. But for a dictionary to delete an entire key, it's a dictionary now, right? It maps their name to the pet. I think that we have to use a del command. Let me go review that. Kind of a weird coincidence, right? Talk about 3030 and we have to use a del command. Yeah, thank you, Pancake. I'm going to show us how to find that out, though. So let's go to our Chrome, check out docs.python.org. You go to the library reference to learn about, how to use different Python commands and stuff. I want to go down to our built-in types and look at the dictionary types. We have, let's see here, Booleans, we have numeric types like integers, we have sequence types like lists and tuples, strings as text, okay? I want to look up the dictionary type, the mapping type. All right, let's see here. So we have this dictionary class, learn all about dictionaries here. I want to find out how to remove things here. So I have the dictionary, okay, all right. Simple type stuff, awesome. Tells you how to use it. Cool beans. Del value, deletes a value, okay, and it raises key error if key is not on the map, that's fine. Okay, so is there another way to delete items from here? I don't think there is. We can clear the whole dictionary, interesting. We can copy it using a method, sweet. We can, this is what Quint was talking about before, and get key and default, nice. Never raises key error, cool. Get the items, okay, actually went for values. Oh, it's a key values pair, okay, that's fine. We get the keys. Okay, cool. Pop items. Removes and returns a key value pair. Okay. So, should we use pop instead of del? Probably not, right? We don't actually want to pop it. That's what my ex-girlfriend told me back in the day. So you can set default. If key is dictionary, return is just value. If not, insert key. What? I didn't know you could do that. That's sick. Something new every day, huh? And value. So yeah, we have to del to remove stuff from the dictionary. That's fine. You can use pop, but it'll return the array, exactly. I don't think I want to. Let's just use del, be more clear of our intentions, right? So basically what John's saying, guys, is that we could use either del or pop to get rid of this item from the dictionary. But pop will give us back the pet, that we popped out of it, which is useful sometimes, but we're not going to be needing that functionality. So to be more clear what we're doing, to the guy who follows behind us, next programmer that follows in this code, let's use del. So it's more clear why we're doing this. We're not going to try and get the value out. We're just getting rid of it. So we're going to say here, del. We're going to say self.pets, and then the key is going to be pet.pet name. So delete this value. He's gone. Yeah, of course, exactly, Quentin. That's why I mentioned that. It removes it, but also gives you the value back. But we don't need the value back, so let's not be confusing and use pop, right? We would use pop if we wanted the value back. We don't want that, so let's not be confusing of our intentions here. And just use del. Okay, so we're deleting that value from the list. The pet's gone, now he went to bed. Sweet. Okay, now I'm going to say here, if the length of our, I think you use length of our dictionary, self.pets, is 0 now. If we have no more pets left, then self. What do we call it? Running, right? Equals false. So now the program is over. Now our game is over, right? We have this running Boolean that determines if our game is still running or not. If we have 0 pets left, it's game over. In fact, why don't we call it game over? Right? We'll say here self.gameover equals false. Right? So it starts off with a value of false for game over. And now we're going to change it to true. If there's no more pets here, then self.gameover equals true. Sweet. Okay, so now we're going to say here, we can clean up the poop as well. We can cheat, then we're going to be done more or less, I think, right? So I'm going to say here, def clean up poop. GameState, it's going to be a self. And we're going to need a pet here for now. That's fine. So say here, if self.poop on floor. So if we have poop on the floor, then say, print off, you clean up the poop. Print a blank line. We could use \n. We're not going to learn about that yet, though. And we're going to say your self.poop on floor is now false again. However, if there is no poop on the floor, then we can print off, there's nothing to clean. Twitch dark theme is better than light theme, huh? I should try it. At least that's how a list, yeah, it works the same way in dictionaries. We looked it up just now. My RAM is getting here on Tuesday. Be patient here, goes. Don't off yourself in the meantime. So we can use that trick I taught earlier, right? Here we have, it's not really integral here, but it's kind of I can demonstrate it anyway. So here we have a method with no return value, and we have an if-else block, right? Now, if this were, more complex, if else block was more complex, it might make sense to try and find a way to minimize the indentation, right? Because we have this little else block here that involves, indenting by 4 spaces. What I can do here, I can say, if this if block triggered, run this code and end the function. Return. Right? So if you made it down this far, we know that this if block did not run. Right? So we save some indentation there, and it sort of acts as an if-else block. You know, an if-else, pair. Because if this first part runs, then it ends the function. If we made it down this far, we know it didn't run. No, dicks. Here goes bot RAM for his computer, so we can actually run Chrome while playing games. I guess sheep are kind of cute. Fuck sheep. Like my uncle. Goats are the best. Goats are the best animal, period. No other animal compares to goats, period. Anyway, so we have this clean up poop function now. It's a method. It's very simple. What does RAM got to do with a computer? I don't know. Goats are trash. What, Centipede? The fuck, bro? I'm gonna fucking ban this dude right now. You know what? I'll let it slide, dude. That's what a goat would do. Goats are always chill. The gout is trash, huh? Okay, so we have this cheat. Let's make a cheat method here. GameState with our pet. Gout is pretty dope, huh? So Dix is a medical student. Just ask DSP. I'm going to say here, print off an F string. Right? It's going to be, Dagger's the dude. How could, I have a typo there. Pet name not love him. Okay, let's break a line there. There you go. Sweet. We finally got Python at my work, but we have to use an IDE called Spider. Does anybody know if it sucks or if it's good? I haven't heard of it. Doesn't mean it's bad, though. Not really a big fan of IDEs in general. I like to use more basic tools. I don't know. With me as the doctor, it's going to be dead, not med, huh? Hopefully not. DSP is the guy who really was really bad at Dark Souls and became a meme, right? I think it was a meme before that. I think it's just a personality, a stream personality. He got hit by a car and the driver got away, but he also sued somehow? But he also hurt it playing touch football. Huh. Well, you have to raise the happiness. It's a cheat code, right? So we're going to max out the pet's happiness. Pet.happiness equals 100. There you go. Sweat. Okie dokie, Smokey. So we're going to end the turn here. This is our last function to become a method. Maybe it would make more sense to have this be a part of an overall, like, take turn method. All right, so let's see what we got here. So we have a new object. It is it's a game state. It represents the whole game. It has a game over flag, a poop on floor flag, a dictionary of pets. We have to find a way to add new pets to that. A food menu, and a command map. Right? Sweet. Awesome. So I'm going to, that's fine. We'll leave it the way it is for now. That's fine. So let's go and make a method called, like, take turn, right? Def take turn. Okay, self. So all it takes is self. What it does is all the stuff we have down here, right? It says here, your pets are, and prints off the pets. Then you choose a pet. Okay. And then you get the pet activity, and you run it, and then you end the turn. Okay, let's just copy paste this code for now. This is our new take turn method. So Spider's pretty cool. It's less popular than Jupyter, but it really depends on how you use it, huh? Okay. So let's go up here and make this a method now, like a take turn method of our object. Okay. So first thing it does when you take a turn is prints off all your pets. Right. So for we'll say for pet name in self.pets. It's a dictionary, right, guys? So the dictionary, if you iterate through it, it goes through the keys. So the keys are the pet names, so we just print them all off, right? Print off the pet name. Easy. Print a blank line after that. We're going to ask for a pet name now. We're going to ask for a pet. It says, take care of which pet, we'll say. take care of which pet? Okay, get the chosen pet name. We're going to try and get the pet now. Okay. Let's see here. All right. Chosen pet. All right. Get the pet out of there. It's a key error. Gonna have a pet by that name. Awesome. And return. All right. Sweet. Now we're gonna get the pet activity, right? So we have a method here called prompt for activity, right? Cool. Let's call that. Let's say here prompt for activity or self dot prompt for activity. Awesome. Then print a blank line. All right. Sweet. Wait. Why is there? Okay. I have to save that to value, right? We'll say here activity string equals self.prompt for activity. Cool. Now we're gonna run that command, right? We'll call this like player command. Player command equals that. We're gonna say here now a self dot what we call our method here for running the command these days. It's called run command with pet. Right. So I'm gonna say here actually just make a new line. Self dot run command with pet. We're going to say here player command and the chosen pet. Sweet. Now I want us to end the turn with this end turn function. Now would it make more sense to just have that all be in here for now? I think it probably would. Let's just get rid of this whole other function and just have it all be a big part of this monolithic take turn thing. So remove this end turn call and instead use just this big block of bullshit. Maybe we could actually stand to break it up a little bit. We're going to leave it this way for now, though. Okay. Indent things a little bit deeper. Okay. Awesome. Sweet. So we made our program a lot cleaner now, guys. And now we can say here, you know, self.gameover equals true, right? Self.gameover equals true. Then print a blank line. Nice. So let's go through how our code works now. Actually, let's make sure it works first of all. Maybe we should talk about Spider in the chat here, huh? Remember how DSP claimed that Seattle Air cured a herniated disc in his back? What? I'm sure you can just highlight the rows you want to indent. Oh, you're right. You're right, John Thomas, yeah. Yeah, I don't really have much experience with idle here, but I can use this format command up here, indent region. I forgot about that. But John is saying here, guys, that I was doing that whole thing. I'm going each line and then 1, 2, 3, 4. 1, 2, 3, 4, right? Every single time. I could just indent the whole block by highlighting it. That's a feature of idle and many other IDEs. Okay, so now our game works way different. We have this GameState object, which has values that the GameState has to know. These are the attributes, right? It has to know if the game is over or not, if there's poop on the floor or not, the list of pets, or a dictionary, I mean, a food menu, a command map. It has to know all this shit, right? Great. In fact, I should probably fill out the command map now, right? Let's go down here and go to our command map as it was. Right here. And copy it. So we have this command map. You know, things you can do, some can't. So, Quentin, for my own curiosity, why'd you get in trouble for mapping strings to callables? It's not really suitable for beginners, probably, to worry about. But I'm curious as a programmer myself. I can't see the harm in it. I fucked that up big time. It's all right. Get rid of this. Okay. Sweet. Break a line here. Hanging indents. You guys know what I do. You guys know what to do. There we go. So now we have our list of commands, and I'm going to make sure these now point to the new methods, not to these old functions. I'm going to say here self.feedPet, self.playwithPet, self.putPet to bed, self.cleanupPoop, and self.cheat. Pretty sure it's all the names of the functions, right? Make sure here. So we have feed pet, we've got play with pet, put pet to bed, clean up poop, and cheat. Okay, so those are all of our methods. Sweet. So now we have this dictionary, or a map, that maps the command they might type in to the method to call. Right? Sweet. We're done. Save it. Let's go down here and change the way our program runs to use this new object we made. Okay. So first of all, I can get rid of all these things. I can get rid of this values right here. That's all gone. Sweet. So first of all, let's make a game state. Let's make a game state. I'm going to say here, you know, game state is a game state object, right? And our game state requires no arguments on instantiation. Let's go review that. If I go up here to our game state, you can see that a init requires no arguments, except for self, which is supplied automatically, right? Compare that to our pets, which require values on instantiation. It requires a pet name, it requires starting happiness level, and a starting hunger level. Same with food. It requires some things when you instantiate it. It requires a food name, a tastiness level, and a fillingness level. Right? But the game state requires nothing. We just gotta just manufacture it. Automatically, it kind of defines some values, right? Defines some values for itself. Like game over is false, poop on floor is false, the command map is filled out automatically. Right? But pets and food menu are not. So let's they start off as being empty. So we gotta fill those up now, right? So I'm gonna say here, you know, GameState.pets equals, right? I'm gonna make a list of pets for this thing, right? So let's go over here. I'll say GameState.pets. Yeah, let's do it this way. What's the best way to do this actually? I'll just say dick sucker. So we're adding some new keys to our dictionary, right? Our pet, dick sucker, 100, 100. So we're kind of taking these from above and making them into keys in this, making them into values in this dictionary. So we have this game state dot pets, you know, Zanzu. Actually, we capitalize in this case. Zanzu. And excuse me, I have to put an equal sign here. A dum-dum. Because we're assigning. There we go. Equals an our pet. That's Zanzu. He has 40 and 40 for his hunger and happiness. GameState.pets KD alpha, capital KD, equals our pet KD alpha. He has 50 hunger and 100 happiness, or maybe the other way around actually. Dick Zuckerberg. That's gonna have to be Dick's handle if he gets banned again. Can you guys believe that my friend Dick Zucker has been banned from Twitch because people have been offended by his handle? What a bunch of idiots. That really pisses me off that Twitch would do that. First of all, his handle is godlike. Second of all, it's not that offensive. There are many, many offensive handles on Twitch. That's true, Dix. That's true, Dagger. There are people that have very hateful handles on Twitch, which sucks, right? If there was something racist or something hateful, that'd be terrible. That'd be terrible. I'd definitely ban that person. But a handle like Dick Sucker? Jesus Christ. Get over it. I had a handle named Swallow My Baby Gravy, and it lasted 5 minutes, huh? Swallow My Baby Gravy. That's godlike, though. I know, I kind of felt it, Dick. I kind of felt like I might have jinxed it. Time for Dick Sucker. You gotta become Dick Zuckerberg, dude. Apparently, the legend goes that when Dix first made his account, it had 1 X in it. When I met Dix, it had 2 X's in it. And I was there when this one got banned. So he had become Dick Sucker with a Z. But I always use this because that's the Dick Sucker in my heart. Is 2 X's. Alright, let's see here. GameState.pets. Vencabot. Equals, you know, our pet. Vencabot. I should stop naming myself versions of Dick Sucker, huh? I don't know. Maybe you should, maybe you shouldn't. Alright, so there we go. So we got Vencabot. So now we have these pets, right? Let's get rid of these then. Boom. So now we have this game state object, and we define all these pets as being values in this dictionary, where the key is that pet's name. Right? Sweet. Let's do the same thing for the food, right? Because you didn't learn your lesson, Dick Sucker. Zix Ducker? Yes, that's so sick. That's so sick. GameState dot, I'll call this food menu, right? I believe it was food menu. Let's go up here and look at it. Food menu. Now, I'll just call it foods. Let's call it foods. Because it kind of matches with pets, right? We have pets, we have foods. Let's go here to our eat, feed pet, right? I'll say here, for pet food in self.foods.values. Okay. So we have this food. We're going to get the food out of there, right? Self.foods, there we go. That'll do. Save it. I used to love making throwaway accounts that shilled for stuff, huh? Let's add this to this foods, right? Self.foods, banana equals a pet food, a banana, 70/20. I'm just going to do this like this, right? I'll say here, get rid of this banana altogether. I'm going to say here, GameState.foods at the pi key equals that. GameState.foods at the mushroom key equals that. GameState.foods at the cheeseburger key equals that. And of course we have our GameState.food at the dick key equals that. Sweet. Awesome. So now we're defining our game here. The game's all defined, which is great. Not sure why there's a print blank line there. Get rid of that. I think it was back when we used to ask for a pet name. Alright. Don't need a pet map anymore either. Or this thing here. So now we can basically just run the turns, right? Yeah. Okay. So that's where we define our entire game state. 2 errors. No, John Thomas, no. Where? Where, John Thomas? Okay, so let's save this. Hopefully John helps me. Maybe we'll see when we try and run it, huh? Gamers deserve to be oppressed, yes or no? He says yes. Oppress me. Food versus food. Thank you, John Thomas. Right here. Yeah, thank you. Right there. Foods. That would have been a attribute error. Or a value error, whatever that's called. Okay, so we're going to say here now, while our game state, we'll say while not game state.game over. So while it's not game over, all I gotta do here is say game state.take turn. Boom. Easy. Then print game over. Awesome. So now we have moved our actual turn-by-turn code into this take turn method. Hey, what's up, Ryan? Welcome aboard, dude. We just finally made our code, object-oriented entirely. There's no more stupid functions floating around. And we have this game state object now, which has these methods that actually run the game. Right? It's sort of an object that represents the game itself. So, will it run? I don't know. How long has it been since we tested it, guys? More than an hour? Probably not. So one thing I have to talk about here, guys, is refactoring your code. If you guys are programmers, you guys know that if you refactor your code, it can make it look prettier, which is great, but you probably had a bunch of typos. I haven't tested it in more than an hour. It's going to probably take a few tries to get it running, but let's see if we can make it work. Yeah, so unbound local error, variable pet, reference before assignment. Let's see, line 141 in take turn. Let's go up here. So when you take the turn here, we have a chosen pet and we have a chosen pet right there. So where is this pet? Pet.hunger. Well, for pet in game state pets. No, we don't have this game state anymore. We have a self.pets .values, right? Those are the actual pet objects themselves. Okay. Let's see if that solves it. Here's another one here. For pet name in self.pets, print pet.pet name. No, don't do that. Just print off the pet name. There you go. Save it, run it, see what happens. Okay, well, it's working so far. You down with OOP? Yeah, you know me. Some of our pets are Dicksucker, Zanzu, Katie Alpha, TF Dagger, and Vencabot. Take care of which pet? Let's take care of Pixel Outlaw, who's not on that list. Oh, so it says here, pet map is not defined. Awesome. So it says here, chosen pet is pet map, chosen pet name. We don't have a pet map anymore. That's our problem. That's from our old code. Right here, pet map. Instead, I'm going to say here, self.pets. There we go. Try it again. Run it. Take care of Pixel Outlaw again. Who wouldn't want to take care of Pixel Outlaw? He's a great guy. Oh, you don't have a pet by that name. Okay, good. So I want to take care of Dicksucker in that case. Do you want to feed or play? I want to put a space after that right away, because that's really annoying. Let's see here. So I want to prompt for input from the player. That's way up here. Prompt for activity. Do you want to feed or play? Space. Space. The final frontier. Save it, run it, try it again. I want to take care of Dicksucker here. Do you want to feed or play? I want to feed Dicksucker. Okay, you can feed the pet a banana, a pie, mushroom, cheeseburger, and dick. I want to feed him dick. But again, I need a space there. Let's go to our feeding code. We want to feed pet name, space. There we go. Okay. I'll run it again. Dicksucker, feed. What do you want to feed him? I want to feed him dick, obviously. What's up, user man? Welcome aboard, bro. Oh, we have a problem there. Okay, cool. My pet's favorite food would be Rolladen? German meat rolls, huh? So right now we have a problem, guys. Our pets have no favorite foods. Instead, every food has a tastiness value. And all pets like tasty food equally. I think as we wrap up today's stream, we might change that. We might change some things how that works. Anyway, so we have a problem here. A GameState poop on floor. We don't have that anymore. It's not a dictionary. It's an object. So let's go to that line here at the end of the turn. Here's our take turn, right? Down here it says, you know, if there's poop on the floor, I want to say here, if self.poop on floor, right? That's our new value that represents that. Okay, then do that. Sweet. Let's try this. Save it. Run it. Take care of Dicksucker again. He's great. How you been doing, user man? Hopefully you had a pretty good week. Feed him some dick. Got to remove some testing code and they literally eat anything, huh? Yeah, they will. Okay, so Dix takes a big dump. Awesome. So that worked. And Dix is kind of hungry, and so is Katie, and so is Vencabot. But he's very happy. But he won't play if he's hungry. So, I'm going to game over here, guys. I have too many pets. They're all very demanding of me. And they're going to kill me, 100%. So why don't I remove some pets and try again? Make it a little simpler. Let's go down here. I'm going to comment out some lines. I talked a few streams ago about comments, right? If you use the hashtag or the pound sign or the number sign, you can make Python ignore a line of code. So I'm going to say here, I want to have Dix, Zanzu, and KD at most. I'm going to comment out, I might even get rid of KD. Comment out that line, see how it changed color? Comment out that line, and comment out the KD alpha line. Now these lines will not run. So now we're only going to have two pets, Dix and Zanzu, like God intended. Run it. Because now I have Dix and Zanzu, I'm going to take care of Dix. I want to feed him some dick. Okay, so now there's poop on the ground, right? I don't want that. I don't want this blank line there. Takes a massive dump. He's kind of hungry, huh? Actually, I want to get rid of this line too. Let's go up here to our feeding code, or our eating code, I think, right? Multi-line comments in Python. Yes, indeed. It's not really a multi-line comment. It's just a string literal. Multi-line string literal. Okay, so let's see here. So I want to go up here to the code for eating stuff. No, for feeding the pet, right? Right here is the problem. I want to get rid of this blank line right there. Eat dick. No, I want that blank line. Then I want to get rid of this one right here after the massive dump. And I want to get rid of the one after they first eat, too. It's just in the eating code. I can smell pizza already. It'll be here soon. It is according to Guido, huh? A multi-line comment, really? You can use it as a doc string. You can use it as a doc string. That's not the same thing as a comment, though. Use a string that is not used, but it works as a comment, yeah. Pizza. So soon, dude. Yeah, I could use a you know, kind of like a userman. I could use a string anywhere as a comment. His word is long. That's crazy. It's his response. So, I mean, I guess maybe it'd be more Pythonic then to just use string literals as your comments from now on. Right, just mix into a big string. He's full of shit. He just misspoke, right? That's baloney. You have to actually, if that was a comment, you have to escape. Whatever. It's whatever. No big deal. Anyway, so Let's, yeah, doc string does the same thing as a comment. I would definitely, you wouldn't want to use a comment. You wouldn't want to use a multi-line string as a comment. You'd want to use, you know, multiple lines with these little number signs. I think Larry Wall's a bit cooler as far as language overlords go. Huh? Who's Larry Wall? All right, so let's see here. So I want to get rid of this extra blank line after they eat to make it more readable. So we have this eat code right here. It prints off they eat the such and such thing. Okay, he does a dance, eats the dick, seems ecstatic. But there's still no blank line. Where did that blank line come from? Report happiness right here is the problem. Ta-da! Get rid of that blank line. Sweet. In fact, we probably should get this is something that Tron Swanson mentioned earlier, right? We could just return a string here. All we're doing is printing a string anyway. So how about we say, well, let's use report happiness. It makes more sense that way. It actually reports the happiness, right? You're not getting a string back. It's whatever. Let's run it. Perl sucks. Yeah, it's pretty gnarly. I never used Perl. So I've got, I want to take care of Dicksucker here. I want to feed him some dick. Okay, so there. Now we have, he does a dance, eats a dick, seems ecstatic, gets a dump, seems kind of hungry. Okay, cool. So I'm going to feed him again. I'm going to feed dick. I'm sorry, I want dicks. I want to clean up, actually. Okay, so now I want to feed. Excuse me, I'm going to say, I want to take care of Dicksucker here. I want to feed him. And I want to feed him a cheeseburger to raise his hunger level. Okay, so now maybe I can play with him, huh? Take care of Dicksucker again. I want to play with dicks. I want to play fetch with, you know, a dick. Oh, he's too hungry to play now. Fuck. Okay, let's say I want to take care of Dicksucker then. I want to feed him another cheeseburger. Now he's super ecstatic again. Now I want to play with dicks. So I want to take care of dicks. I want to play fetch with a dick. There you go. So we retrieve the dick at lightning speed. Right? That means he's very, very happy. Okay, I want a blank line after I input my command. Let's go up here to our playing code. Play with. Alright, so I want to print off a blank line first of all. And I want to, well, you know what? Fuck that. I want to actually print off the blank line after they type in their action. Right, let's go up here to our GameState, go to our take turn method. And after you choose an action, right, which pet, okay, get proper activity, print blank line. What? How come I didn't get a blank line then? We're going to play fetch with. Oh, I'm sorry, that's after the fetch code. I'm stupid. I'm stupid. Let's go up here to our throwing code for playing with. You throw the toy. I want to print a blank line first. We're going to play fetch with. Oh, well, that's up here, actually. Okay, I'm sorry. I'm stupid. It's up here in the play with pet code. Print a blank line. There we go. I'm dumb. Why is there so many blank lines right here? I guess because you print off a blank line whenever you start a new round. Where's the take turn code? Prints off your pets are. Okay, where's all these blank lines coming from here? This is so 1995. Yeah, making this virtual pet program in all text. Stop playing with dicks on stream. I would, but it gets me the views. I found out a bit ago that Perl's extremely similar to Ruby syntactically, which is interesting, huh? It's just a bit arbitrary sometimes, and you can write some really unreadable but cool one-liners. Even in Python as well, you gotta be careful. These comprehensions can become a little bit deep. It could be COBOL, but COBOL isn't terrible, it's old, huh? Python greater than everything. I agree with Entropython. Python is God. I wrote in COBOL today. It's not very well designed, huh? The mainframe programming. That old school shit. Let's go up here and figure out why we have these two blank lines. So Dix retrieves the dick with lightning speed. Let's go up here and find out why. And here's our pet. It can play with stuff. You throw the toy, blank line. And then it prints off, they retrieve it with lightning speed. There was a, you throw the dick, blank line. Okay, they fetch it. Prints off a blank line. So that should be fine. Oh, because we printed off the end of the turn, there was some blank lines. Oh, I see what's going on here, I think. Let's go down here to our game state, and the end of the turn, where are these blank lines coming from? Right here. Okay, right there is a blank line at the very end of the turn. Is that necessary? I would say yeah. Cool. So what I want to do here is I want to actually get rid of this line. I want to get rid of the blank line after you throw the toy. And also after we're done playing. There we go. Why is it self.hunger though? Plus equals 20. That's supposed to be the pet's hunger. Oh, this is the pet. I'm sorry. Okay, I'm sorry guys. Let's save it and run it. We should be fine now. Rating COBOL in 2019. What? Yeah, my friend Ryan is, he likes to get off on historical programming. He's a very cool guy. Follow him on Twitter. He sometimes builds old computers and writes software for them. He experiments with old languages. I think it's kind of a cool hobby. There are still AS400 systems emulated in the business world, unfortunately. Really? Run the module. So take care of which pet? I want to take care of Dicksucker. Oops. I want to feed him first. I want to feed him some dick, make him maximum happy, but also maximum hungry. He takes a big shit afterward. I want to take care of Dicksucker again. I want to clean up after him. Son of a bitch. Dicks again. I got to feed him twice to make him full enough to play. 2 cheeseburgers. Cheeseburger. Cheeseburger. Now you can play. So now we can say here, I want to take care of Dicks. I want to play. I want to play fetch with, you know, tennis ball. Okay, so you throw the tennis ball. Dix retrieves the tennis ball with lightning speed. Sweet. Okay, so I think everything in our game works. Let's try and I want to take care of Dicksucker. I want to put him to bed. Is that the quit command? Yes, so he goes to bed. Okay, now we have Zanzu. Take care of Zanzu. Feed him a cheeseburger. Okay, now he's in high spirits. Let's put him to bed now he's in high spirits, right? So I want to take care of Zanzu. I want to quit, put him to bed. There we go. So now it's game over. We have no more pets left, right? Sweet. I know that they're in the government sector. A lot of Chicago's real estate appraisals are logged in a COBOL mainframe. Wow. Kind of surprised the business world hasn't fully moved to SQL or anything else. Are you surprised? These fuckers are lazy as hell. Guys, our game completely works again, and now it is a little bit easier to read as well, and formatted in a more object-oriented way, which is kind of nice. Right, we have this GameState object, which saves these values to itself, and it can use these values in its methods, because every method always gets access to self. So we can actually find out, and all these methods can kind of read the game over state, the poop on floor state, the pet state, all that stuff. It's beautiful. It's so beautiful. Like Quentin said, if it were my own private, you know, software, I probably would have broken it up by now into more than one piece, right? Because it is a little bit much. It's one big tower of code. It clocks in 182 lines, and there is a lot of stuff here. But for a beginner, it makes sense to have it be in one file. It's not that long, and it is not that hard to read. So speaking of which, not being hard to read, let's go through one more time, guys, and review how this program works to kind of end this season of Entropython. I'm not sure we're gonna have time to add new features after all, but at least it's given us a chance to talk about object-oriented programming and about methods, attributes, functions, all these ideas we need to learn as Python programmers. Let's go through it and see what's really, really good. So we have 3 kinds of objects in our code, right? We have this pet food kind of object. It's a mold, a class for manufacturing pet food. You have to supply a name for that food, a tastiness level, and a fillingness level for that piece of food. And we use it down here to make all these foods in our food dictionary, right? Here's our pet food class, manufacturing a new banana, manufacturing some pie, manufacturing a mushroom, right? These are all just kinds of pet food. And they're all, although they have their own attributes for a name and tastiness and fillingness, they all are also from the same mold. They're very similar. They all have these same attributes, right? They all have a pet. They all have a food name and a tastiness and a fillingness. So although we are using this mold, they are every instance, right? Every instance of that class, every object from that mold has their own special attributes. we also have this our pet class, which defines one of our pets. Right? They all have a pet name, and a starting happiness level, and a hunger level. And they can use their methods to change their happiness or their hunger, or check their happiness or hunger, because when you have a method, it always has access to self, which is the instance that's calling that method. Right? So it's kind of a cool way to think about how and why you organize your functions and variables into objects as methods and attributes, because you have to think to yourself, conceptually, does it make more sense to have this variable belong to another variable, right? Like, do they all belong to the same idea? In this case, of course, your pets, they all have a pet name, and a happiness level, and a hunger level. So why not have them all be a part of this idea of a pet, right? Because they all are attached to the same thing, conceptually. And furthermore, we know that when the pet eats, it has to know these things. It has to be able to change the happiness and the hunger. It has to know the pet name, right? So if, this eat function really does mostly center around this idea of this pet, why not have it be a method instead of just being a function, right? Because it really has to have access to this pet. It makes sense for the pet to be able to do this thing, therefore it's a method, right? So speaking of which, we have this eat method here. It takes one argument, which is the pet food it wants to eat, right? It checks that pet food's tastiness level and uses that to do some things, right? It might dance if it's really happy, if it's a really tasty food. It'll change its own happiness, right? It changes its own happiness using self. If it's a really kind of nasty food, it might lower the happiness, right? It prints off some stuff, including the pet's name and the food's name. And it has both of these objects to draw from. It has self, because it's a method, and it has the pet food as an argument. So we have both these objects, and we're using their names in this string. And finally, our hunger is changed based on the food's fillingness level. And then we report our happiness. And we're calling our own method here, right? Self.report happiness. It's our own method. This method here, all it does, it prints off a string that kind of gives the player an idea of how happy the pet is without telling them explicitly how happy the pet is. We could just say here, pet's happiness level is at 73. But instead, we use this sort of a loose value to make it a bit more exciting for the player. It's not exactly, it's not an exact science. Right? It kind of prints off these values based on how happy the pet is or is not. Okay, so the pets also have a play with method, where you give them a string, this toy string, and what you do with it is you sort of throw this string, and the pet will retrieve it, really, really fast or kind of lazily, depending on how happy it is. It's kind of another way to gauge how happy the pet is. And its hunger goes up, right? If you play with it, its hunger goes up. And it will not play if it's not happy enough to play. Again, one more way to see how happy the pet is. And I think we'll get rid of this blank line here. And if it's too hungry to play, it gets pissed off if you try to play with it, right? Instead of feeding it. These are both good spots to use some F strings as well, right? We have a string here being concatenated with a string, right? Why not make it into an F string? That's a more modern way of doing it. I love F strings. Shout out to the Python developers for adding that feature. There you go. There's one right here too. Screw the old-fashioned concatenation. Let's just use an F string. F, it means format, by the way. It formats the string using these, or formats these variables into the string. Okay, cool. Sweet. And when you throw the toy, again, it reports to happiness, raises the hunger level. That's how you play with the pet. And finally, the pet can dance, a very silly function. We kind of use this to learn about methods in the first place, because it uses self.petName, right? Very simple little method there. We used it once in our feeding code. If it gets a really tasty food, it dances. Right? In any case, a very simple method here. Let's just change it to an F string. Right. Excuse me. There we go. All right, cool. All it does is print a little string for you. All right, now we have this GameState object. It's our newest object and probably the most complex. It represents conceptually the whole game. Right? This is the game. You use this to kind of make the game. Right? And when you initialize it, it takes no arguments at all. But it does initialize some values. Like the game overstate, it's always false when it first starts. Right? So the game is running, and the poop on floor value is always false when it starts. And it makes an empty list, empty dictionary, I mean, for both pets and foods in the game. And then it has this command map, which maps the strings that the user might type in to the method to call when they type it. And it's a dictionary that maps a string to a callable, in this case, a method. And then here's our other methods in our GameState, in our game, and you can see that they pretty much all use, for the most part, the GameState's variables, which is why it's important that they're methods, right? For instance, it has to know if there's poop on the floor to prompt for the activity. If there's no poop on the floor, then you ask the player to either feed or play. But if there is poop on the floor, you ask them to either feed, play, or clean. Right? Likewise here, when you run the command the player asked for, it has to know the command map. Right? That's an attribute of this game state. So we can say here, get the command the player wants from this self.command map, because it knows its own command map. It's a method. It belongs to this object. And then it calls it there. Now we can feed a pet, right? It requires a pet argument. These all require, for the most part, pet argument to kind of work with. And it says here you can feed the pet, gives you a list of your foods you have. And then it says here, what do you want to feed them? Okay, you choose a food. And then from the food you chose, it gets the actual food object. So the food you chose is a string. You typed in a string, right? But now that string will point toward a pet food object. And that pet food object has, tastiness, and it has fillingness, and it has a food name. So we use this string you typed in to get the actual pet food object from our self.foods dictionary. Remember, the dictionary is it's a bunch of pairs of strings to the pet food objects. Right, so you typed in the string, now we're going to use that to get the pet food out of that dictionary. Okay? And then we're going to have the pet eat that food. Right? Again, the pets have an eat method. So we have this pet object. Right? We know it's a pet object, and we know that we got it as an argument. Right? So we have this argument here, pet. That points towards our pet object, right? An instance, I should say. And that instance has an eat method you can call. We remember that the period sign in Python refers to ownership. It's kind of like an apostrophe S in English, right? We're saying here, use the pet's eat method. So pet.eat, chosen food is the argument. Let's go up here and look at that again one more time. So here's our eat method for our pet instances, and it takes a pet food to eat. Right? And then it uses all this stuff here. It takes the tastiness and it messes with the fillingness and it changes values of the pet based on all that stuff. Kind of like a game would do, right? So you feed the pet, it eats the stuff. It says here, if the pet's full, it takes a big poop. We change our game state's poop on floor value to true. So now our overall game has this idea that poop is on the floor. And the pet's hunger is being changed as well. And the pet has a hunger value that's now back to 100. We can play with the pet here. First, I ask you for a toy string to input. It doesn't really matter. The toy is just a string in this case. It's not really like an object. We could make it an object, right? We could make it like a object that changes the pet's happiness based on how fun the toy is. Toys could have a funness value, right? But for now, it's just a string. And we need that string to just print off stuff. Like, you throw the ball, the tick fetches the ball. It doesn't really matter what it is. It's just a way to make it a little more interactive. But yeah, so take this toy string, you get it from the user, then the pet plays with it. There's a toy string there. You can put the pet to bed using the quit command. That'll simply put it to bed there, print a little message for you, and also removes the pet from the game's list of pets. That way, we have one less pet to worry about in our game. We talked about last time about how it could be fun to have pets sleep for a while, then wake up again. That could be a very tactical tool in a game to sort of control their hunger and their neediness. Right? If you have 5 pets, maybe you can find a way to put 2 to bed, and then kind of, over time they might wake up and be a pain in your ass again. But for now, you can kind of ignore them. It's sort of like could be a game mechanic. We didn't really get around to that this time, though. No, Ryan. Smother with pillowcase, pet. We would never do that to our pets. We put them to bed, dude. They're sleepy little boys and girls. And anything in between. We can clean up poop in our game, right? It requires this pet object, even though it never uses it. See this? It never requires this pet object. Right? But we still use the pet object here, because when we run this command up in Yang, when you run this method here, run command with pet, it always requires a pet. Every command always requires a pet. So just to be uniform, we still use the pet argument there. You want to see how that works? I think we talked more about that on episode 3, I think. About why you sometimes give uniform arguments to methods and functions, even if they don't need them. It's sort of a... It's not the best way to go about doing things, but for a beginner it kind of makes sense. Likewise, here we can cheat. It takes a pet argument. This time it actually uses it though, right? It actually uses that pet argument to raise that pet's happiness. So this is a cheat code in our game that automatically raises your happiness to 100. It's kind of cool. And finally, we have this very important take turn method. It's a little bit longer than most. This represents the entire turn that you take every time you take an action with your pet. So the first thing that always happens is it lists your pets on every turn. It's all your pet names. Right? Ask you which one you want to take care of. You choose the one you want to actually interact with. And then it will prompt you for an activity for that pet. Right? It says you want to play with or feed Zanzu. Right? And then we also have this, part where we run our command with that pet. So it'll either feed or play with it or put it to bed or clean up its poop. All that stuff happens right here. Self.run command with pet. The player commands the string, and then you have your chosen pet. And finally, once that's all done, we've run our command, then the turn ends, and we finally kind of finalize that turn. We say, hey, for every pet we have, so we kind of go through every pet we do and ask these same questions for each one. Is that pet's hunger greater than 70? If it is, we tell the player they're hungry, and they lose happiness because they're hungry. If there's poop on the floor, then that pet becomes less happy. And if the happiness is 0 or below, then they bite us and it's game over. They ask that question for every single pet at the end of every single turn, right? So that's kind of like adds challenge of the game. Even if we only interact with Dicksucker, Zanzu could still be losing happiness if there's poop on the floor. While pet is alive, pet that draw. No, Quentin, no. We would never do that. And that ends our turn, right? So now finally, up here we defined all of our classes, the pet food, the our pet, and the game state. We defined how they all work and how they behave and stuff, but we haven't used them yet. We just defined them, right? Up here, all a bunch of definitions. And then down here, we finally utilize this stuff. I'm actually going to get rid of all these to make it simpler. Actually, I'll just put them on the game again, so we know what's up. I'm going to break it up a little bit visually, right? Like this. There we go. So here's where the game actually starts, where we actually initialize things. We make a game state from our mold, from our class, right? We instantiate the game state class. So here's our instantiation, here's our instance, the game state. We manufactured one. So now this game state can do all the things that we defined for game states to be able to do. It has attributes and it has methods that they are defined by its class, the game state. Right? And here we are changing, or we should say we're updating some of its mutable attributes. Right? So our pet's attribute of a game state is a dictionary. So we can add things to it. We're adding in new keys. So we're adding in all these pets, right? This Dicksucker pet, it's a key, a string, that points toward an our pet instance. Right? We have all these strings that point toward our pet instances in our dictionary of pets. Right? The dictionary, the map, will map the name of the pet to the actual pet object. Right? And we do something for the foods, right? We have this foods dictionary, which maps the food name to the food object. And here we have, the food name banana, and it points toward this pet food instance, which is, a banana. For all these things, it's all the same, right? We got pie, mushroom, cheeseburger, and dick. And finally, we defined all of our stuff. We defined our pets, we defined our foods. Now the game starts right here. It says, while not, GameState.GameOver. So know that a while loop, the second half of the while loop, is a Boolean value, right? Like Boolean value goes here, right? And you could have it be something like a comparison. You could say like, if, game state, you could say here, while game state dot pets Dicksucker, dot happiness is greater than, 50. What we're saying here is get a Boolean value from this comparison operation, right? So this will either be true or false, right? Is Dix's happiness greater than 50? It evaluates to being a Boolean. Right? It's going to be a Boolean one way or the other. There's a parse it. I got Dicksucker, my homeboy. But we're going to be using something a little bit more overt. We're going to be using a Boolean value, but reversing its value, right? This will only run while true. And the game over state defaults to false, right? The game is not over. So we're going to say here, while not game state dot game over. So the not keyword will reverse the value of any Boolean that follows it. So the game over state is false, right? The game is still running. So while not false, or in this case, while true, then keep on running this one line of code. GameState.takeTurn. You're my homeboy, Dix, whether you like it or not, dude. Back off, homeboy. So as long as the game over state is not true, we will keep on running this code, right? This take turn method. And take turn is a method because it requires access to all these attributes and methods of the game state, right? It's always a good idea to make something into a method. I should say always. It's often a good idea to make functions into a method if they require access to this object's attributes and methods. Right? So we need to know, like, you know, if there's poop on the floor, we got to know how to use commands. These are all, you know, stuff that belongs to this game state. So that's why we use a method here. So by running this take turn method, as long as the game state is, you know, not in a game over state, then we're good to go. We've made our game work. We define all of its behaviors up here, right, as methods essentially and classes and attributes. And then we, you know, defined our instances, our game state instance, all of our pets, all of our foods, and then we just run the game right here forever, right, until it's game over time. And there you go, guys. That's our game for this season. If you guys want to make it even better, it's going to be on GitHub, by all means. Copy the code and add new features, add in the ability to sort of put pets to bed and have them wake up, add more, you know, food properties, add, you know, certain ways that pets might prefer certain foods. That could be fun. Maybe certain pets like certain foods better than other ones do. That would make sense. It's all well and good, guys. But I think we're going to end this season here. We're kind of out of time. It's now 9 o'clock. I got to get this movie going here pretty soon. But guys, as usual, if you guys enjoy hanging out, learning about Python, check out my Patreon page, patreon.com/Vencabot. Even $1 is a huge help. I stream for 40 hours a week, every week. It's a variety stream, lots of gameplay, a little bit of development. But on Fridays, it's always Intro to Python this time slot right now. It's a lot of fun, guys. What should we do next week? Right? We finished our season here. So how can we move on in Intro to Python Season 5? What should our game be next time? Barca says home, huh? Pet.rectal prolapse. No! Yes! Yo, thank you, Dagger, for the bits. That's a lot of bits right there. That's going to make this pizza easier to afford. Using mutable game states, bad, Venka. Well, it kind of has to be, right? For a game state. Man, that's just for Haskellers, huh? They don't actually produce anything, just read white papers. You could, you know, you could worry a lot about mutability, and maybe you should, and to a certain extent. But I think for a game state, I think that kind of makes sense to have it be a lot of mutability there. Lots of little attributes and stuff being swished around. Again, we're a variety stream, guys. We stream all kinds of cool content here. Starting very shortly is our pizza and a horror movie night. We're going to be watching a film together and eating pizza. It's public domain. I'm going to be streaming it here on Twitch. It's no big copyright problem. You can watch it right here with me and enjoy the vibes if that's your thing. After that, it's going to be some Minecraft. But guys, if you want to help out and you really can't afford Patreon, totally understand, guys. That's not unusual for guys of our demographic. I wish I could support more streams. Not really in a spot to do that financially. That's fine, though. You know, help for free. Get in the chat. Come say hi. Ask questions. Come hang out. Offer suggestions. Check me out on Twitter at Vencabot. Check out YouTube at youtube.com/Vencabot Archive, or just search on there for Vencabot. You'll find more tutorials for Python, including seasons 1, 2, and 3 in their entirety of Intro to Python. And this season as well, very shortly. I think mostly all of it's all up there right now. But this episode's going to be going live probably in a couple nights. But we also have, again, lots of gameplay, Third Strike, RPGs, retro games, modern games, horror games, shooting games, multiplayer type stuff, more movie nights, more cartoons, all on YouTube. It's got more than 1,000 videos, and a new one goes live every single day. It's a lot of work. Go subscribe if there, please, if you're into that kind of thing. I will see you guys very shortly, though, with a pizza and a movie. Until then, peace out. That'll be going here in a few minutes. Gonna watch Casper the Racist Ghost again, Venka? It wasn't that racist. The most racist cartoons we watched were the Betty Boop ones. Dick's no report for copyright, bro. Come on. Just have a million parameters for it to knit. Problem solved. Yeah, but it still has to change over time. Thank you, Dick. That's actually what I use. I use that list. I use some other lists as well to find public domain films. Not a whole lot you can do. You have to gamble against Alex and Hugo. And other characters that are command grab centric. I'm pretty proud of how this program came along, guys. Here we go. It's not really as feature rich as I hoped it would become, but I did get to go into more depth than I often have about objects and stuff. So I think it's probably worthwhile for the amount of learning we did. We could have forced more features in, but it would have meant a faster pace overall. Let's go, Quentin. We should watch that on stream, dude. So Ryan only really uses functional programming for recursion and tree walking. The rest of the time I mutate like a Teenage Mutant Ninja Turtle, huh? That's funny. I try to keep it clear, more or less, you know, what the methods are doing. I do like that aspect of, you know, functional programming, the idea that you have to kind of supply arguments and get return values back. I tried to keep it very clear what's going on if I can. Parser, are you on our Discord server?
The liquor, I'm sure some of you guys
I can't click on that link right now and explore it, but if you want to go there and share it with me on Discord, I'll check it out when the stream's over.
Look at that. Liquor butthole.
I'll be right back, guys.
Zombie male, Catherine Warren, that's the mayor.
Alright, here we go. Oh my god! Well, the pizza's here early, and I don't mind. Your boy Vencabot don't mind.